Namaste and good evening, good afternoon and good morning, depending on where you are joining in from. We are now going to start the webinar. My name is Dundi Raj Pathak, your host today. I'm a geotechnical and geoenvironmental engineer based in Kathmandu, Nepal, and executive member of Nepal Geotechnical Society and scientific committee and editorial team member of Geomandu 2024 and international conference series of Nepal Geotechnical Society. I do research and university teaching by passion, but mostly involved in consulting sector in the field of integrated waste management and landfill engineering, in addition to traditional geotechnical engineering. It's indeed my great pleasure to be a part of this important event. And foremost, I would like to welcome IGS President Dr. Anil Joseph, NGS President Dr. Mandeep Savedi, Chair of Geomandu 2024 and immediate past President of Nepal Geotechnical Society, Professor Dr. Netra Prakash Bhandari, our distinguished speakers, Mr. Arvind Kumar Mishra from India and Dr. Ganalal Shrestha from Nepal. The speaker of closing session of today's program, Professor Nilima Satyam, respected members from host organization and esteemed participants from different parts of the world to this special webinar on Indo-Nepal webinar for geotechnical excellence, jointly organized by Indian Geotechnical Society and Nepal Geotechnical Society. This is our first program in region in MOU signed between IGS and NGS in 2023 and aims to foster the cooperation between the geotechnical community of Nepal and India. The collaborative effort signifies a commitment to advancing the geotechnical engineering by sharing knowledge, expertise, and experience to enhance the geotechnical practice and promote the excellence in the field of addressing the common challenge in the region. Before we proceed, I would like to introduce today's program and speakers briefly. We'll be here for nearly 1.5 hours, exactly 1 hour and 25 minutes. Since now, this webinar is composed of opening remarks from the President of IGS and NGS, to invited presentation, and question answers session, remarks from the chair of Geomandu 2024 to invite all participants of Geomandu 2024, and the closing remarks. I would like to thank to Engineer Rajan Kesi, Treasurer of NGS, and Engineer Ujjwal Nirola, the Secretary of NGS, for their technical support for today's program. With this note, I would like to request Dr. Anil Joseph, the President of Indian Geotechnical Society, to deliver his opening remarks. The microphone is over to you, Dr. Anil.
Yeah, very good evening, all of you. So the moderator, Dundi Raj Pathak, the President of Nepal Geotechnical Society, Mandeep Savedi, very good friend, immediate past President Netra Prakash Bhandari, the speaker from Nepal, Dr. Ganendra L. Shrestha, the speaker from India, Arvind Kumar Mishra, so committee members from Nepal, my fellow International Network Committee Chair, Murli Krishna, TC Committee Chair, Nilima Satyam, Secretary, Dr. A.P. Singh, and the distinguished members in the panel, and all those people who have joined for this webinar, for this Indo-Japan joint workshop. Very warm good evening to all of you. It's a pleasure for me to address this gathering to give a brief about Indian Geotechnical Society. Before I start, I would like to thank Netra Prakash, who has initiated this entire program by inviting us to Nepal in last March, where we had the opportunity where 4 of us who is from India, from the National Committee, were there in Nepal, and that starts the beginning of a very strong relationship with each other. And with the support with Mandeep, we have came to an MOU in Roorkee, where we signed that, and as the part of that, Mandeep initiated this process where we will join together for the Indo-Nepal cross-border conferences was planned, seminar was planned. So congratulations, Mandeep, for taking the initiative, and thanks to A.P. Singh, who took the lead from Indian side to get it collaborated. I would like to say a little bit brief about Indian Geotechnical Society. And hopefully you are able to see my screen. Yeah, Indian Geotechnical Society is headquartered in New Delhi, India, and we were established in 1948, India's premier body of geotechnical engineers. And we were affiliated to the International Society of Soil Mechanics and Geotechnical Engineering, right from the starting in 1948. And we have an IGS journal published by Springer, and we have started our annual conference since 1983, and 40 conferences has been completed so far. And we have a dense array of local chapters spread across 54 chapters now, and we are inaugurating the 55th day on 10th of this month, and more than 6,000 members, and all major knowledge institutions are part of this, and many professional societies, including ISSMG is our connectivity there. And we are very, very represented in the international forum, where we have more than 93 representatives in committees of ISSMG. Three of our members, Dr. K.L. Rao, Dinesh Mogan, and Professor M.R. Madhav, have served as the Vice President Asia of ISSMG, and several TC-supported international symposiums were held in the past 2 to 3 years. And IGS members regularly present conference in these sort of events. And generally, in the past 14 years, we have about 16 ISSMG supported conference, and we have the opportunity to host the first Asian Regional Conference in New Delhi in 1960, 5th Asian Regional Conference in 1975, 13th Asian Regional Conference at Calcutta in 2007, and we are also fortunate to host the 13th International Conference on Soil Mechanics and Foundation Engineering. We share a lot of common grounds with each other, and also we have the 12th International Symposium on Field Monitoring in Geomechanics, which is going to happen at Indore in India, which will be led by Nilima Satyam. So this is a little bit brief about the Indian Geotechnical Society, which we want to share with my brothers from Nepal and the members who has joined from India. And thank you very much for taking the initiative. And together, let us try to improve our geotechnical engineering knowledge and share with each other, because like Carl Tarsaki told, the soil is an element which varies horizontally as well as vertically. And the many theories which is proposed are only approximate. And unless and until you have a real feel of the substance, we don't have that. And the best way to get more knowledge is to share the knowledge with each other. Let us discuss our success and failures and make sure that this system continues and we keep improving and sharing our knowledge. All the very best. And once again, I congratulate the entire team to making this webinar happen. Thank you.
Thank you very much, Dr. Anil Joseph, for your valuable opening remarks. Now, I would like to request Dr. Mandip Savedi, the President of Nepal Geotechnical Society, to deliver his opening remarks. Dr. Mandip, open to you.
Thank you, Dhunti sir. Are you getting me?
Yeah.
Yeah. Ladies and gentlemen, President of IGS, Dr. Anil Joseph, resource persons from today's webinar, Dr. Gyanlal Shrestha, and Mr. Arvind Kumar Mishra, geotechnical engineers and geoscientists from Indian Geotech Society and Nepal Geotech Society, and also the professors and scientists joining in this webinar from the globe. Greetings to you all from Nepal Geotech Society and myself, Mandip Subedi. It's an honor to address and shortly brief about Nepal Geotech Society as the president of this society. Yeah. Nepal Geotech Society is a leading scientific organization established on 18th May 1994. It is a self-governing and self-profit non-profit entity dedicated to advancing the field of geotechnical engineering in Nepal, fostering collaboration and promoting innovation in infrastructure development. Nepal Geotech Society, NGS, is a leading scientific organization Since our affiliation with the International Society for Soil Mechanics and Geotechnical Engineering ISSMG in 1995, NGS proudly represents Nepal as one of the Asian member national societies of the World Forum for Geotechnical Engineering and Professionals. Our commitment lies in advancing the welfare of Nepal and the global human society through our work. Till now, we have around 500 individuals and 28 institutional members. Now, I would like to highlight our organization's regular activities. We publish newsletters, proceedings, reports, and also planning to launch a journal. Our international biennial conference series, Geomandu, provides a platform for experts to exchange ideas. Additionally, our annual celebration like NGS Day strengthen community bond. We engage members through monthly lecture programs and special youth initiatives like geotechnical models and photography competitions. Moreover, we offer valuable opportunities for professional development through trainings, workshops, and research grants. Lastly, we take pride in our awards and recognition programs honoring outstanding contributions within our community. Nepal, nestled in the Himalayas, presents myriad of geotechnical challenges due to its diverse terrain and seismic activity. Despite of these challenges, we have undertaken numerous projects that showcase our expertise and resilience. One such sector heavily affected by landslide is the road infrastructure. The Kathmandu-Tarai Fast Track Project, Narayangarh-Mugling Road, Kaligandagi Corridor, construction of road tunnels, upgrading of Nepal highways, development of East-West Railway, and modernization of airport are also few cases where significant geotechnical challenges are encountered. While geotechnical experts are employing new and innovative techniques, there remains a continuous need to address these challenges and learn from experiences abroad. Additionally, our work in the field of hydroelectric power generation has been paramount. Nepal's abundant water resources offer immense potential for geotechnical projects, and our geotechnical expertise has played a crucial role in the construction of dam, tunnel, and water plants. With projects such as the construction of a total of 400 kilometer long tunnels and the successful completion of 2,836 megawatt of hydropower generation till now, we are striving towards the target of 20,000 megawatt in a few 10 years period, harnessing the potential of our natural resources for sustainable energy production. Furthermore, our efforts extended to various other sectors where extensive geotechnical works are underway. These include the development of new cities, construction of high-rise buildings and star hotels, advancement in the tourism sector, establishment of landfill sites, and the construction of dams to support irrigation and water management. Our involvement in these projects underscores our commitment to advancing infrastructure development and fostering economic growth to Nepal. However, Nepal faces significant challenges posed by disaster and climate change. According to ADPC 2020, Nepal ranks 4th in the world in climate change vulnerability and 7th in landslide with floods, earthquake, and gulf, having extensive impacts. This is a pressing need for a climate change-induced disaster-resilient infrastructure development framework. Geotechnics for sustainability is the utmost important in migrating these challenges and ensuring the long-term resilience for our infrastructure. Moreover, our engineering relationship with India plays a crucial role in advancing geotechnical engineering practices in Nepal. The signing of an MOU between NGS and IGS during the IGC 2023 Roorkee marks a significant step toward fostering collaboration between two nations. Additionally, Many Nepali students pursue their geotechnical education in Indian universities, contributing significantly to the manpower to this field. Collaboration between the Institute of Engineering Nepal and the Institute of Indian institutes like IIT further strengthens ties and facilitates knowledge exchange. Furthermore, the adoption of Indian codes and standards in our design process, along with the utilization of Indian individuals and institutional expertise in Nepal, underscores the synthesized relationship between our countries and advancing geotechnical engineering practice and addressing common challenges faced by the construction industries in this region. This collaborative effort signifies the commitment to mutual growth and enhancement of infrastructure development across border. Thank you very much.
Thank you, Dr. Mandeep Subedi, for your enlightening talk, shedding light on the history of Nepal Geotechnical Society and its innovative endeavor for the geotechnical advancement towards the sustainable and resilient infrastructure development in Nepal. Now the time is to listen to our invited speakers' presentation. Our first distinguished speaker is Mr. Arvind Kumar Misra. Mr. Misra is a well-known professional in hydropower development in India and Bhutan. He devoted 46 years in the design, engineering, construction management, and contract management of major hydro projects. Mr. Misra did his bachelor degree in civil engineering in 1977 from Georgia University. Thereafter, he did his master's MTech in soil mechanics and foundation engineering from IIT Delhi. Mr. Misra is the life member of and a fellow associate member of the prestigious institution, professional bodies of the world. On 7 December 2023, he has been conferred by His Majesty of the King of Bhutan, the highest civilian award at Thimphu on 116th National Day of Bhutan for his outstanding contribution in the development of hydropower project in Bhutan. Mr. Misra has authored around 40 technical papers, which have been presented and published in the proceeding of the conference and seminars. The title of today's presentation is Analysis of Highly Fragile Deep Slopes and the Dam Abutments in Himalaya. With this brief introduction, I would like to pass the floor to Mr. Arvind Kumar Misra and request him for the presentation. The microphone is over to you, Mr. Misra. You have about 23 minutes for your presentation.
Thank you very much. First of all, before I start my presentation, I may like to convey my personal thanks to Anil Joseph ji and Mandeep Subedi, R.N. Mishra ji, and A.P. Singh, who have played a vital role in organizing this conference, video conferencing. And before I start, I just would like to share that while working in Bhutan, the curiosity of mine, professional curiosity of mine developed when you must be aware that the Punasanchu 1 hydroelectric project, 1200 megawatt, is under problem since July 13. Till date, the right abutment of the dam has not been stabilized. And for the first time in the world, the piling was used as a support to transfer the loads and to stabilize the right abutment. So my curiosity was based on these concepts, that whether the stabilization measures adopted there are correct or not, number one. Number two, whether we should keep on working the old conventional methods of analyzing dam and slopes the way we were doing for last 50 years. Third, should we make a change? In this regard, I am personally thankful for one of the conference which was organized by Professor Ravi Jaka in collaboration with the University of Texas, US, in which the discussions were held, and I was one of the participants there regarding the non-linear analysis. So I would like to share some of the points on the non-linear analysis, in which we will think of compositely about dam and abutments together, And whether this type of analysis will help or not, this is one of the point I wanted to bring in my discussions. Then the second point I wanted to bring in the discussion is piling, how the piles are behaving and how the piles are being done. This is another area of interest for all of us. Third point, which I'm just trying to touch, is the vulnerability of the old dams with respect to seismic aspects, because this is a very important thing for all of us to realize that once the dam is old, the properties which we have considered at the time of designing, they deteriorate. And for the same earthquake conditions for which it was designed, if you subject the dam to those earthquake conditions, you will find that there is a failure.
Mr. Sir,
So
the video
I
is
want to cautious all the participants, especially the geotechnical engineers, that we should draw the attention of the community, professional community, towards these 3 points. Number one, whether we should go for NLA, that is non-linear analysis for dam. Number two, whether we should use piles, deep piles, big diameters, as big as 2 meters, as deep as 70 meters. Third is the dams which are existing. Should we reanalyze them, keeping in view the research has taken place in the last 50 years about the fragility of the dams because of the various factors which probably we have not considered when we were designing the dams. And the third is, rather fourth, that what are the activities which Bauer, German company working in India now as an Indian outfit, is doing in this country with respect to the geotechnical engineering. These are the 4 points I want to cover, just to agitate your mind that whether we should think in this direction and improve our thinking towards the design of the dams. Next. So let's have the presentation slide wise. So the first is ultimate lateral resistance to piles in cohesionless soils. The risk assessment of the age concrete dam subjected to material deterioration under seismic excitation. Screen is visible to all the audience.
the sound was muted, sir. Now we are listening.
Why it is not running?
Now it is okay, sir.
The screen is not shared. If
Yeah,
Yeah, we can hear you, but the screen is not changing, you know, the same screen is still there.
you can stop it and again start the sharing. It will work.
Yeah.
Arvind sir, you stop the sharing and then again share the screen. It will work.
it is shared. Start. Second. I'm not able to read. See, look at the just conceptually, I have given few points. Piles have been used extensively for supporting the axial and lateral loads. In many cases, lateral loads governs the design of piles. The ultimate lateral resistance is required to be calculated through use of PY curves. Ultimate resistance to laterally loaded pile in three-dimensional, and it is a non-linear problem. Next.
I think you have same problems again. There is no change in slide.
Now it works.
Next slide. Now if you look at the research has been done in last more than 30 years, there are concept developed about how the piles are behaving under lateral loads, and for which various lateral loading on the pile has been worked out through the research work. And there are 5 concepts. If you look at the literature available, you'll find that the research has been done, shows the variance of the lateral loading on pile, and where the pile is socketed in the rock, you'll find a passive stress on the one side, and the other side the lateral load through the overburden and the material, and this behavior is basically changing with respect to the depth of the pile as well as the diameter of the pile. And the main concept which has been brought out is that when pile is sheared off or pile is basically getting displaced, then what is happening? Then broadly it is worked out that twice the diameter of pile is having the bulk resistance, which is creating the resistance to the lateral load. The diameter of the pile, if suppose it is 1 meter, then the influence area which one pile can create is 2 meters. That means the lateral thrust which it can resist is the pile diameter itself, and the 1 meter, that is 0.5 on the one side and 0.5 on the other side. So this one pile can resist about 2-meter thickness as a lateral loading on the pile. And this has been contested in the research. There are viewpoints that the resistance can be more also, but it is broadly believed for the safety purpose that this can be restricted to the twice the diameter of the pipe. Next. This is what the people have done. I have just brought out. Next. Just next. This is the Q plus F which I have given, that is ultimate lateral resistance offered, that the ultimate frontal normal reaction and the net ultimate lateral shear drag. The sides of the pile on the both sides will resist the lateral thrust. So Q plus F is the ultimate lateral resistance exerted by the pile on the soil. Next. This is just a small diagram to show you that if there is a lateral thrust F, then how it is getting resisted by a pile, possibly. So what I am talking about, that if the diameter is D, half D, that is D by 2 on the up and D by 2 on the bottom. So almost 2D is getting resisted by the diameter D. Next. This is again the calculations, simple calculations. Third, Q and F can be worked out. Next. This is the factors which have been considered for a circular and square piles. Next. Then the second point which I have brought out here is the risk assessment of the aged concrete dams. This I have brought out with respect to this thinking that most of our dams which are 30 years old or 40 years old, they are subjected to the deterioration in the elastic modulus. The surface elastic modulus value is lesser than the value which is inside for which it was designed initially. And how it is getting deteriorated, how the deterioration factor works out, that has been done a lot of research by the engineers in past 30 years. And they have proved that if you subject the dam to the same seismic load, dam might fail. Next. This is what I worked out. The degraded Young's modulus is 1 minus d upon E naught. That is d is the degradation factor. This is how the things have been viewed now. Next. This is I just want to share here that 285.5 meter high Zhanglo arch dam in China indicated 65 to 110 mm abutment movement after initial impoundment. This has created significant increase in compressive stress in the arch dam. When subjected to strong earthquake, the abutment movement results. My point is that if there is a saturation in the abutment and abutment is fragile, there's a tendency to compress the dam body. This particular case, it is an arch dam, but even if there's a concrete gravity dam, the same phenomena will happen. Both the abutments will compress the dam body, which is a rigid body, and it will additionally create the compressive stress in the dam body, which in turn will increase the tensile stress at the foundation level. That means there's a compounding effect. This was the latest research which Chinese have done, and they have cautioned that we should be very careful when we are designing the dam. Abutments cannot be ignored. If the abutments Young's modulus value is not matching with the concrete, if they are on the lower side, there's a high possibility that under saturated condition, when the impoundment is done, the material may move towards the dam and it may compress the whole dam body. If it is so, the resultant thing would be that there is a high compressive stress in the dam body, and in turn it will increase the tensile stress at the foundation level, which is not good for the dam, because there is a possibility of a tensile crack at the foundation level. So this is what has been analyzed and has been seen in one of the dam in China. Next. Now, why we are talking about go for a linear versus nonlinear analysis. The point is that if you look theoretically, there is a geometric nonlinearity within the dam body or within the abutment. You'll find this exists. Second is the material nonlinearity, means the material which we consider uniform right from bottom to top. If we take an abutment, then it is not a correct assumption. The properties of material keeps on changing as we go from bottom to top, and this non-linearity is never taken into account. Similarly, when it comes to the dam foundation contact, you'll find that the contact, we take a straight line. That is not a straight line. When we go for a theoretical analysis, we usually go for a slide or overturning values when we work out in a conventional manner. For a concrete gravity dam, we usually work out the factor of safety, and we assume a contact which is linear, a straight line, which is not true, because in the field it is having a lot of undulations and high undulations. Those features are never taken into account. Conventionally, for last many years, we had been doing only overturning and sliding analysis. Now, if you take into account the geometric nonlinearity, the material nonlinearity, and the contact nonlinearity, you come closer to the real truth. And once you come to the closer truth, you'll find better results. So my thrust or why I'm putting up this to all the geotechnical engineers before that, let us look into these aspects. These are important aspects, and it is happening. They are happening in the ground, and we have to take into these factors in our analysis. In fact, the joint nonlinearity in modeling during construction joint, lip joints, and development joints, apart from our concrete nonlinearity behavior modeling, including cracking model, plastic models, foundation nonlinearities, including rock joints, slippage modeling, also the jointed rock material behaviors model. If you look at the conceptually, if you see this stress strain curve, and the linearity when you take, when the stress is proportional to strain, there is a straight line. And if you go for non-linear, there's a non-linearity. And if you look at the gap, that means the upper bound and the lower bound, in a simple sense, you can say. So the engineering judgment lies between this upper domain and the lower domain, where you should fix up. Because if you go for a linear analysis, you are always on a straight line. And if you go for a non-linear analysis, you are a little lower. There's a depth, there's a gap between the two. And this gap is a human judgment or designer's judgment, whether you should stick to values to the upper bound or you should go for the lower bound. So this is what basically is important, that whether whatever stresses we are calculating and declaring the factor of safety, are they correct? Are we considering the non-linearity which is actually there on the ground into consideration or not? And the difference is quite big. So my thrust is that now the time has come, we should promote non-linearity in our analysis to make dam more safe and improve the factor of safeties, because this is what is required now. Next. Procedures to take into account the nonlinearity behavior, the constituent material, that material nonlinearity, joints, cracks, supporting structures and foundations caused by mechanical, physical, and chemical processes, by external loads, restraints, and degradation processes. These are very important parameters, and they are there, but they are getting overlooked or ignored because of various reasons. But now the methods and the processes are available by which we can take into account these factors. Next. The nonlinear, if you look at the procedures and tools to solve nonlinear static and nonlinear dynamic analysis, you can do both. If you want to have static, nonlinear, you can do it. If you want to have a dynamic analysis, nonlinear, you can also do that. Specific minimum requirement selection of softwares. Zepdyne is available for nonlinear analysis now. Guidelines for selection of material parameters, values for nonlinear analysis. The bulletin disregards the geometric nonlinearity. There are conceptually, if you look at some of the section of engineers do not advocate for geometric nonlinearity except in the arch dam. But some advocate that there is a nonlinearity in the geometric selection also. Next. This is the conceptual things I just brought out for nonlinear behavior. Next. This is how the, if you look at what happens actually in real life, that how the cracks develop under the loadings. Next. This is how the conceptually the elastic, plastic, and elastoplastic ranges do occur. Next. This is how the non-linearity affects, including the results, test results. Next. Again, the related properties, effects on the properties. Next. This boundary non-linearities. So what, move next. 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 material nonlinearity. Next, go back to that. That concrete in tension, concrete in compression, rock foundation. These positioning, I mean to say, if the tensile stress is there or the compressive stress is there, the rock foundation, the some area might be having tensile stresses, some area may be having compressive stresses. So the conceptually, if you look at, the uniformity is not existing. The some area of the foundation might be subjected to compressive stresses, some area may be tensile. So there is non-uniformity all along, usually which is overlooked if you go to the conventional analysis. Next. 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 These are the constitutive laws for rock foundations. Broadly, the point which I have just spoken, that how to take into account the nonlinearity, this is brought out here. Next. Now, after this, I wanted to share with you the how to improve the geotechnical aspects, especially when I was doing this project in Bhutan, Magdechu. The consultants were of the opinion that we will go for permission grouting, but I did not accept it because we were to go about 70 meters below the riverbed, and the permission grouting under a matrix which is having silt more than 18% will not work if you look at the literature. Then when we analyze the matrix of the riverbed, we found out the silt is about 28%. So the doing permission grouting under those conditions will not help. Seepage cannot be controlled. So we went for a cutoff wall, and I have shot that cutoff wall into a video. I'll just show you how this has been done in Magdechu, placed by Bau, Germany. Next. No.
The sound is not coming.
cubics, which is 1 in 25 years flood based on peak discharges in the monsoon season. Two gates of sizes 3.5 meters wide and 8 meters high for each opening have been provided to facilitate the closure of the tunnel and plugging of the tunnel before reservoir filling. Cofferdams are conventional rock-fill dam type, as the depth of the overburden in the riverbed at upstream cofferdam site is about 40 meters, and the height of the cofferdam riverbed is 15 meters. The seepage through the cofferdam and the riverbed is likely to pose constructional problems. A positive cutoff up to the bedrock is required so as to keep the dam excavation pit relatively dry and carry out the excavation and concreting works below the riverbeds. The cutoff could be of the following types: the diaphragm wall, or the jet grouted cutoff, or the permission grouting alone.
Not very much. So that if you go to a concrete cutoff wall, as I spent money on this, is about 2 lakhs per square meter. The cross-sectional area which I plugged through cutoff is about 4,500 square meter. About 90 crores we spent on the cutoff wall. But if I go for a permission grouting, I would have spent 60 crores. But then the 15 crores in the BOQ bill of quantities I kept for dewatering was totally saved. I did not spend a single penny on the dewatering in the dam pit, even though we were so much below the riverbed. So this is the advantage. The purpose of showing this slide is that most of us engineers, initially we go for the economics, and we prefer that the method which is cheaper, we should go for that. Had I gone for a permission grouting, I would have saved some money, no doubt. But the risk of seepage would be very high. And if it is not controlled properly, the first lift of the dam, which is the lifeline for the entire dam, will be risky. And you will not be doing a good quality work because there won't be a bone dry condition. This is what is important. Magdechu has been done in a record time of 7 years, date of award, date of completion, at a cost of 5,033 crores. This project has been done with the help of Government of India as a bilateral project, totally funded by Government of India. So this is one of the example I have just shared with all the engineers who are participating with us. And there are other slides also I have taken just to apprise the participants the magnitude of the project. This project was having 13.5 kilometer long tunnel, 6.6 meter dia finished, and two distilling chambers, the pressure shaft, surge shaft, and the underground powerhouse. Similarly, in the underground powerhouse, just for your geotechnical aspect, I would like to say that there was on the long walls of the powerhouse, the low dipping shear zones were there on both the walls, and we were advised by the consultant again to shift the axis of the longitudinal axis of the powerhouse by 40 meters, which we did not do. And we did the powerhouse there only, in spite the advice of the consultant. And we went for a numerical analysis by NIRIM at Bangalore, in which we established that the shear zones on both walls can be treated, and we can do the powerhouse there only. And we have changed the methodology and the supporting system in the ground powerhouse and succeeded in doing there by saving 1 year for the project and about 15 crores cost. So this is what the overall picture is. There are many slides I have collected, but there's lack of time, so I can't show you the lot of things on tunnels also. But I think I'm running out of time, so I'll share all this with the participants by circulation. Thank you very much.
Thank you very much. I'm sorry for interrupting you because we have a very limited time. Thank you, Mr. Mishra, for your insightful presentation. I'm sure there are several questions to you, but we will take all questions later in the question and answer session afterwards, or we request to all the participants to put your question in Q&A box. Then we'll consolidate all the questions and send to our speakers.
Sure.
Now, our second distinguished speaker is Dr. Gyanlal Shrestha from Nepal. Dr. Shrestha is the president of Nepal Tunneling Association and work as a senior consultant specializing in geotechnical, tunnel, and hydropower engineering. Currently engaged in hydrolab and various projects financed by the ADB, World Bank, across the multiple countries. Dr. Shrestha brings extensive expertise to his role. He holds a PhD in tunnel engineering from Norwegian University of Science and Technology, and an MSc in geotechnical engineering from University of Birmingham, UK. Before joining to any engineering company, Dr. Shrestha gained a valuable experience at the Lower Modi hydropower project and several other hydropower initiatives. He specializes in tunnel stability analysis and support design and utilizing empirical, analytical, and numerical modeling techniques. He has contributed significantly to the field through the numerous publication in the peer-reviewed international journal, national journal, and magazines. Furthermore, he is the author of the book, Rock Engineering Handbook on Design of Tunnel and Other Underground Structures. The topic of today's presentation is tunneling in Nepal, Himalaya, and associated risks. With this introductory note, I would like to pass the floor to Dr. Shrestha for his presentation. The microphone is over to you, Dr. Shrestha. I request you to finish your presentation in 20 minutes. Thank you very much. Dr. Shrestha.
Thank you very much, Mr. Dhundiraj Pathak, moderator of this program, respected President of Nepal Geotechnical Society, Dr. Mandeep Subedi, and the respected President of Indian Geotechnical Society, Dr. Anil Joseph, and my presenter, respected Arvind Kumar Mishra, and fellow geotechnical professionals from all over the world. Namaste and good evening from Nepal. In last few decades, Nepal has made very good progress in the design and construction of tunnel and other underground structure. So today, the topic of my presentation is tunneling in Nepal Himalaya and associated challenges. Let me share my slides. I hope you can see my slides now.
Can you show in presentation mode?
Yes, yes. Now it is in presentation mode. Can you see now?
Not yet.
Not yet. Okay.
It's visible,
Sometimes
but not in presentation mode.
Okay, that happens when we use a window like this. Maybe I have to continue with this mode, I believe. Sometimes it doesn't work. It comes in my screen as a presentation mode. Does it change?
Yeah.
Yeah, okay. So I have about 28 slides, I believe, and covering tunneling history of Nepal and the present status of tunneling in Nepal, and the brief introduction of Nepal Tunneling Association as well. And then I have a few slides on advancement in design and construction technology. And I will also share some slides on the challenges encountered and measures we have applied while carrying out tunneling in Nepal. I go to the tunneling history of Nepal. The use of underground space is not new in Nepal. Especially the early generation used underground caverns and tunnels of smaller dimension for shelter and tombs. It was especially in Mustang district in the northern part of Nepal, and also to extract the minerals and metals for tools and coins, and also for irrigation purpose. There has been construction of tunnels and underground structure. There has been more than 1,000 underground structures in Mustang district in Nepal. Those are more than 2,000 years old. If we Google in National Geography Amusing Planet, we can still see those photographs. And those structures are still existing in northern part of Nepal. So this tunneling and underground structures are not new in Nepal. Those are more than 2,000 years old. And similarly, for mining purpose also, during the Malla era, that is about
Sorry,
2000
Garana,
years.
sir. I'm sorry for interrupt you. Is it not slideshow view? Can you show in slideshow?
I try, but it doesn't come. Can you see in slide mode? Presentation mode, it doesn't come. It comes to my screen, but it doesn't come to the audience, I believe.
Yeah, okay. Please go on.
That's why. It is in presentation mode in my computer. Just to give you a kind of history of tunneling and underground structure in Nepal. That we do have first irrigation tunnel built 200 years back and is still in use in Palpa district in Nepal. Similarly, 107 years before, Surya Mai tunnel, road tunnel was constructed in Nepal. When world famous Tony Hagen visited Nepal in the early previous century, and then he has noticed that one, and he has written in his book that that could be very first tunnel in Asia itself. But for many decades, the development of tunnel and underground structures, was not didn't make any progress. And the modern tunneling history actually started in Nepal from Tinau hydropower project 50 years back in 1974, where first modern tunnel was constructed and first underground cavern was also constructed. Then in last 5 decades, we have built many tunnels, caverns, and shafts like that. And then some of the database we have prepared in Nepal, like a first drinking water supply tunnel, which has got the longest tunnel in Nepal, longer than 27 kilometers in length. And first sewerage tunnel is only half a kilometer long. That was built 24 years back. And the modern history, first mining tunnel was built in 1985. It was in operation few decades before, but now it is stopped now. And the first TBM tunnel was started in Nepal very late, and the one project was completed with the length of 12 kilometers of tunnel in 2018. And surprisingly, we do have a short tunnel for the Saligram Museum in Bangalore district. It was built 6 years back. And nowadays, we again started constructing a road tunnel. You can see the central photograph at the bottom. Very short road tunnel that was built about 10 years back, is still in operation.
Your slides are not changing.
Okay, so let me go to, sorry. That's why I wanted to be in the another mode. You see now? Is it changing now?
Yes.
Yes.
Okay. In this mode, it changes, but we cannot see in the presentation mode. Now it changes.
Yes.
Yeah, I have got few photographs of the first rock cavern on the left bottom, and the central bottom is the road tunnel, first road tunnel being used by the public vehicle, built 10 years back only. And the bottom right one is the Saligram museum tunnel in Bagroom. I just wanted to give you the present status of tunnels in Nepal by use. Though we have collected database with 416 kilometers of tunnels have been constructed in last few decades. Out of them, it was the hydropower projects which are using tunnel mostly. So far, more than 350 kilometers of tunnels have been constructed for hydropower projects. And then some other projects and other tunnels are for drinking water supply, irrigation, sewerage, road, mining, and museum. We don't have any railway tunnel and metro tunnel yet. And more than 300 kilometer tunnel is in construction. And for the plant projects in the future, we are going to have more than 600 kilometers of tunnel. Hydropower projects is in very good progress in Nepal. At present, there are 157 hydropower plants in operation now. Out of 157, 60 hydropower projects do have tunnel as the project component. And at present, 114 hydropower plants are in construction now. And 40% of those projects do have a tunnel as the project component. Of course, most of those projects do have a surge shaft, which is underground structure. And there are big hydropower plants in planning, as our NGS president also mentioned. About 38 big hydropower projects are being implemented, still in planning. And then that will add another 252 kilometers of tunnel. Similarly, regarding the water tunnel, we are using double seal TBM for Sunkoshi Marine multipurpose project. Now, I want to give a short introduction of Nepal Tunneling Association. As a tunneling industry is booming, and then many geotechnical professional friends are involved in this sector. So we have started Nepal Tunneling Association, especially to share knowledge and experience in this area. It was established recently in 2011. And this is a registered member nation of International Tunneling and Underground Space Association, ITA. And we have got only 160 life members and 10 corporate members so far, but it's growing very fast. And we conduct annual international conference and training. We do deliver lectures to the master's engineering course on the rock and tunnel engineering in Institute of Engineering in Pokhara. And then we keep record of excavated and planned tunnels in Nepal. We conduct tunnel program, talk program on different aspects of tunneling. And of course, we advise and support Nepal government and other organizations in tunnel related issues. I want to share a few slides to highlight advancement in tunnel construction technology in Nepal. In the past, we started with very primitive drilling method applied in the 50 years back. Still, we are using it for the small size tunnel. But nowadays, fully mechanized fill and blast method and the robotic application of circuit are commonly applied for large size tunnels, and which helps to construct a large size project in a short span of time with a good quality of workmanship. And recently, as I have mentioned, that we have completed 12-kilometer long tunnel with tunnel boring machine, and the second project is in progress for a 13.5 kilometer long tunnel that will be completed in next 2 months. Just to share some slides about the basic tunnel design method we use here is, of course, we use empirical method using mostly rock mass classification system, and we also apply analytical method, mostly closed form solution, and the numerical modeling extensively we use. The present trend is for planning and feasibility stage. We use mostly empirical method based on rock mass classification. But for detailed design and construction phase, we use the combination of empirical and numerical modeling as well. So in this regard, most of you are aware that this is just one example of the support chart we use from Q system as a part of the empirical measure. And then we go to the numerical modeling so that we can calculate stress, deformation, and other parameters to analyze stability of the underground structure and to check the support capacity, whether it is enough or not. Based on that, similarly, because Nepal is situated in the very young mountain, Himalaya, and then we are very prone to squeezing issue in Nepal. So we always check whether we are expecting squeezing risk or not. For that, we draw a line. Above the line, squeezing issue is expected, and below the line, we are safe from squeezing problem. And based on the analysis, different types of analysis, we come up with the support chart. Usually, we classify rock mass in 6 classes: class 1, 2, 3, 4, 5, 6, and based on the rock class and the dimension of the underground structure, and then we prescribe different types of support class. And then we prepare final support chart like this. On the x-axis, we can see the Q value or rock mass quality. And on the x-axis, we provide overburden depth above the tunnel. Sometimes what happens is we may have rock mass quality, with magnitude 2, and for the 100-meter overburden, we are happy with class 2 support. But for the 300-meter overburden, for the same rock class, because of the overburden increase, we have to go to class 3. And with the increase of the overburden, for the same rock class, we have to go for the higher support class. And of course, if we need, we have to go for the support class for squeezing condition as well. In a short time, I have tried to cover a few topics. At the end now, I want to share a few challenges we often encounter in Nepal Himalaya while carrying out tunneling, and then measures we have adopted. I will start with the squeezing issue. I have taken this issue from Chamelia hydropower project. It is not a big project. It's a small project, 30 megawatt installed capacity. And the tunnel was excavated with inverted D shape, 5-meter dia it had. But due to the squeezing, this 5-meter dia tunnel reduced to the 3-meter dia. And we had to revisit the investigation data and the support calculation. And we came up with a solution. From the inverted D shape, we went to the circular shape. And the support also we revised to accommodate the squeezing problem. Now it is in operation. The second challenge, common challenge we encounter is the stress problem. We have completed one project, we call it Upper Tamakosi, 456 megawatt project. During the site investigation, in situ stress was measured by 3D overcoring method at the powerhouse site, and it resulted with sigma 3 value about 5 MPa. Based on that, pressure headrest tunnel was designed. But when construction, progress made to start the headrest tunnel maximum pressurized section, and then to verify the sigma 3 again, hydrofracture test were carried out. But at the location where sigma tree was very important, sigma tree was measured up to only 1.2, 1.9, which is much less than it used to be. We expected about 4.5, but we had only 1.2, 1.9 like that. So we had to have a major change in this project. So 5-kilometer long tunnel has to be realigned. Actually, it was not fully excavated. Only a small section was excavated. That's why from the pressure tunnel, high pressure tunnel, we had to make it a low pressure tunnel. And then we had to add a vertical pressure shaft, which is still lining. And of course, actually, these changes caused extension of time, and then the cost also overrun. So third issue I want to share with you is the problem we encounter while crossing shear zone. In most of the underground construction in Nepal, we encounter shear zone. Sometimes it's manageable, a small one, and sometimes it is a difficult one. And then one example I have brought up here is the construction of incline shaft. This is the actually pressure shaft. This is from Khimti 1 hydropower project. It has a 684-meter head. So we do have incline pressure shaft divided in two sections with horizontal landing in between. The bottom incline pressure shaft was successfully excavated with less problems, but the top incline shaft, pressure shaft construction was not easy. When it was excavated for about 186 meters in length, it started encountering difficult shear zone, and then we encounter very big overbreak and with water flow as well. And then it took 319 days to manage it. So at the end, we had to abandon this one, and we had to go 50 meters further inside the hill, and we started again construction of the inclined pressure shaft. And it went well until it reached the same shear zone where overbreak was encountered in the previous one. But this time, actually, we were prepared. So we managed to overcome this one, and we continued from the bottom, in fact. And towards the top, when we reached 352 meters in length, then we started having overbreak in another shear zone. We had multiple shear zones, actually. And it was so difficult with 8 liters per second water and then shear zone. And finally, it progressed, the overbreak progressed to the surface with the sinkhole formation. And then work was stopped for almost 11 months. It took 11 months to stabilize and then again change the support. And then we provided reinforced ribs of circuit. And the rest of the section we excavated from the top to bottom. Then finally it was, stabilized and the construction completed. Now it is in operation. One more issue we always encounter, not always, but most of the time we encounter, is construction of tunnel below road highway. One of the case I have brought up here is construction of the tunnel, headrest tunnel, below the national highway from Pokhara to Baglung. you can see a small car on the top, and then we had a 14-meter overburden and above the tunnel. Unfortunately, we didn't have bedrock here. We had to construct a tunnel in alluvial and colluvial soil. So we had to work very cautiously with the mechanical excavation and the application of ribs and spiling, of course, circuit and rock bolt and drainage system, and then providing final concrete RCC concrete support of 30 centimeter, and then we did it about 40 meter before we encounter bedrock, and it is in operation now. Last challenge I am sharing with you is water ingress problem in the tunnel and other underground structure. This is very, very common problem in Nepal. In most of the tunnel and underground structure, we encounter water ingress problem. Sometimes it is in a small discharge, so we can manage. Sometimes it's difficult with running ground. And this is the one of the problem with hydropower project headrest tunnel. When we wanted to establish edit and headrest tunnel junction at the depth of 110 meter, rock mass was found to be very, very poor with Q value 0.1 only. And then groundwater, initially it was 6 liters per second, but then it increased very fastly to the 35 liters per second for many months. Poor ground with water, it was not possible to have a junction of the edit tunnel and the headrest tunnel. So we actually excavated more the edit tunnel. Luckily, the ingress water actually moved with the advancement of the tunnel face. So what we did is we used 13 meters of the tunnel as a water, chamber, drainage chamber, and then our design location was water free. Though the ground was weak, but without water. So we were able to manage to establish this edit and HRC junction at that location by moving the ingress water location towards the heap site. There are other many issues, but because of the shortage of time, I wanted to share only few of the issues with you. And then so with these few slides, and then this some sharing, I like to close my presentation. Thank you very much.
Okay, thank you very much. Can you stop your slide?
Yeah, I will do that.
Yeah, thank you very much, Dr. Freshter, for sharing the insightful presentation, shedding light history and current status of hydro tunnel in Nepal and innovative solution for solving tunnel-associated challenge in Nepal Himalaya. I hope all our audience have found it to be a very informative. Thank you again. I request to all participants to put your questions in Q&A box. Because of the limited time, we consulted all these, your concern, and we'll send to our your concern to our speakers for their response. But now I would like to invite Dr. Netraprakash Bhandari, professor at AIME University, Japan, and the chair of Geomandu 2024, an international conference series of NGS, and our scientific committee member and editor of Proceeding of Geomandu 2024. Professor Bhandari is also immediate past president of Nepal Geotechnical Society. And because of his hard work and continuous encouragement to our young geotechnical engineers, NGS attained the new height. Thank you, Professor Bhandari, for your great contribution to bring the NGS in today's position. Professor Bhandari, the microphone is over to you. You have about 5 minutes for your talk.
Thank you, Dr. Pathak. Thanks very much for the time. Very good evening. It's midnight here. I'm sorry, I'm feeling a little bit sleepy. Very good evening to everyone in the network. This time is just for, maybe all of us know that we will be holding one international conference in this coming November. So I just want to introduce that conference to all of you participating from India as well as from Nepal. So let me just share my slides and then probably I can work on that. So this is a conference that we had one last year, March, and then this year also, because there's a gap of, we wanted to do it once in 2 years, but because of the corona, we had to postpone that to March. So this year we'll be holding this on 20th and 29th of November 2024. So the topic, the theme of this conference will be Geotechnics for Sustainable Infrastructure, and that will be held in Kathmandu on those two days. And so this is all about like what we'll exactly do. This for a research presentation as well as some network building. So all of the things are as usual in all conferences. And the conference themes are basically geotechnical, geotechnics, and geohazards or geoinfrastructures. All these things will be there. And for details, you can just take a look at this conference website. And the important dates are, we had March 15 as the abstract submission deadline, but we have extended it up to this month 15th. And then we'll go for a full paper submission and all those stuff by at least up until 1st of September. And the conference committees and all those things are here. We'll be publishing all papers, all submitted papers in the proceedings with the Springer. And we have a team of 5 people in the editorial for the editorial stuff. And this is a slide that shows the keynote and distinguished lecturers that have promised to be in the program. And we have a long list. We have at least 20 distinguished professors and keynote speakers in the program, from all over the world, from Japan, India, USA, even China, and the IICCG people will be joining us too. And from India, we'll be having a lot of support from all over all our colleagues in IGS. And the submission of paper is still open. So until 15th, we'll be accepting all those abstracts. And this is the system that we will be using for submission of abstract as well as full papers. And the participation fee for international people will be US $300. And for SARC participants, including Indian colleagues, it will be US $200. And the students will get a 50% reduction, and the accompanying person will have to pay about $150. So this is the current status of our submission, this abstract submission. The biggest number is from India, and we're very much thankful to all our colleagues from India. 63 abstracts have been so far submitted, and from Nepal only we have 18. So we're expecting that the number from Nepal will be increased in a few days. And we're expecting some more papers from Japan as well as from other countries as well. So we are expecting at least maybe 150 papers by the end of abstract submission deadline. So this is the current status, and the contact details are like this. So we are expecting that a huge number of international people, including from India and SAARC countries, at least 100 to 150 international participants, as well as 300 to 400 domestic participants. So altogether 400 to 500 people will be in the conference. So we will welcome you all to Kathmandu, to Geomandu 2024. Thank you very much.
Thank you very much, Professor Bandari, for your valuable remarks with the highlight of Geomandu 2024. Now we are end of today's program. Before requesting to our guest for concluding remarks, I would like to request to R.N. Mishra. He is the ex-CMD of SJVN Limited for his quick comments within 2 or 3 minutes.
Thank you very much. And I'm very grateful that you have invited me and asked me to give few comments. The webinar was really very educative, and Mr. Mishra and Mr. Shrestha both have given very good insight of the problems. Mr. Mishra has actually emphasized on certain aspects like non-linear analysis about the piles and how we should reanalyze the dams. These are the things really which the geotechnical engineers, geotechnical experts should look into, and we should really see what changes we should bring in so that we construct better and more safe structures which are cost effective as well as which do there is no time overrun. So that's a very important thing. And one thing I would say that whatever we do in hydropower projects, the most important issue is the investigation stage, how we have investigated. If we have the proper investigation data and we give proper emphasis at that time and we prepare our detailed project reports, then a lot of problems can be avoided. And the about the tunneling in Nepal, Mr. Shrestha has given very good insight, and a lot of progress has been done. And actually nowadays in the tunnels, a lot of new developments are also taking place, whether in terms of construction methodology or in terms of your geotechnical engineering, how the supports are to be given. And so all these things are really very important. And especially whatever we do, ultimate thing is that how do we construct it? It means that during construction, how the project management is done. That is very important. But for all whether the project management will be good only when the designers and the geotechnical engineers, they have done their job and they have given a good project in the hands of the project implementers to implement it. So it was a really very good session. And thank you very much for inviting us to this conference, which is going to take place in Kathmandu. And I hope that from India as well as Nepal, more and more people should participate in that and get benefited. Thank you very much and all the best.
Thank you. Thank you.
Thank you very much, R.N. Mishra. Now, I would like to request Professor Nilima Satyam. Dr. Nilima Satyam is the currently professor in the Department of Civil Engineering at IIT Indore, and she holds PhD and MTech from IIT Delhi. She published more than 150 papers in international and national journals and conference and received the several prestigious fellowship and awards. She is the fellow of JSPS, IGS, and she is presently editorial board member of the several reputed journals, including Nature Scientific Reports, Journal of Rock Mechanics, and Geotechnical Engineering. I invite Professor Nilima to conclude the program with our closing remarks. And this is host DR Pathak is signing off. Goodbye. Professor Nilima, over to you.
Yeah, thank you, Dr. Shrestha. Good evening, everyone. And I'm sorry, my throat is very bad today. So actually, we had a very good lectures, which is being taken the challenges from both Bhutan Himalayas and the Nepal Himalayas. So I was just trying to make few observations. The first talk, like Mishra sir has very clearly explained the challenges, basically not only in the construction, even in the analysis part, like where non-linearity, issues has to be material property, especially. The second thing is like in the second lecture, where Dr. Shrestha has explained not only the history of tunneling construction in Nepal Himalayas, he also tried to express some of the squeezing issues, which is also common in our Indian Himalayas also, because India being the fifth, producer in terms of hydropower in the worldwide. So we do have several similar challenges, especially in the squeezing rock mass and also the water ingress. So thank you so much for bringing this information or the insightful lectures in this particular webinar series. I congratulate both the societies, IGS and NGS for coming together and making this webinar. So thank you so much. And yeah, thanks everyone.
Thank you very much. And
Yeah, thank you.
It's our